ஸோ வணக்கம் நண்பர்களே, மீண்டும் ஒரு வீடியோவில் சந்திப்பதில் மகிழ்ச்சி. ஸோ லாஸ்ட் கிளாஸ் கண்டினியூஷன் தான் இன்றைக்கி பார்க்க போகிறோம். ஸோ அதுக்கு முன்னாடி இப்போ தான் நம்ம சேனல் வரீங்க, நம்ம சேனல் சப்ஸ்கிரைப் பண்ணிவிட்டு கூடவே பெல் பட்டனை ப்ரெஸ் பண்ணுறீங்க நண்பர்களே. ஸோ இன்றைக்கி வீடியோவில் நம்ம ஒரு இம்பார்ட்டன்ட் டாபிக் தான் நம்ம டிஸ்கஸ் பண்ண போகிறோம். மெக்கானிக்ஸ் ஆஃப் எ சிஸ்டம் ஆஃப் பார்ட்டிக்கல். So the mechanics of a system of particle, we have to take two masses, then m1 or m2 with respect to the position vector from three-dimensional at center of point or center of mass we have to calculate. Just we have to draw the diagram, we have to understand. Okay, so if you take the three dimension, then x, y, z. Okay, if you take, this is the center of the mass, so this is the origin O. So if you take then mass mi, then another one with respect to center of the mass we have to take then mj. So this is the position vector ri vector, this is the position vector rj vector. So if you take, we have to draw the three-dimensional x, y, z. We have to draw the center of the masses with respect to mi with position vector ri, similarly then mj with position vector rj. Okay, so first point, let us consider. So let us consider a system of particle, system of n particles on which external force so if you consider this is the system, we have to apply n particle by using external force. This is the first point. Then second point, let ith particle of the system having mass mi and position vector ri and jth particle having mass mj and position vector rj. Okay, so this is the important point we have to understand. Then similarly we have to there should be two cases are important from this position of center of mass. So what are all that? Then position of center of mass depends on first one, that should be a shape of the system. So the center of the system is the important point, the whole shape of the system. Then second one, then distribution of mass in the system. So in this place only we have to distribution of mass in the entire system. So this is the sum of the construction we have to understand before going to the derivation part. Okay, good. So next we have to find out the important things, that is the r, that should be a position vector, that should be capital R, can be write it as, that should be m, then summation I, that should be ith particle with respect to number of particles, that should be then mi, then ri vector, then divided by then summation mi, then I vector, then n vector. Okay, so from this denominator, so if you see that, then from the denominator, then summation I n mi can be written as that should be a m, which should be a total mass. From equation can be rewrite, then r vector, this is, that should be a way to put 1 by m, then remaining term, then I with n number of particle, then remaining mi, then ri vector. Okay, so then after that, then summation in this term, then mi ri vector can be written as then total mass with respect to r vector. Okay, just enough wrong, we have to cross multiply this one. So okay, so similarly next we move on to the total force. For example, total force, there should be a then Fij, there should be a then ith particle interact with j particle, then ith particle interact with jth particles. Okay, about total force acting on ith particle can be ith particle of the system. How to write? About total force, then Fi vector, which is equal to then Fi, this is the external force, plus then vector, then summation j is equal to 1 with respect to number of the particle n, then Fij vector, this is the equation number 1. So in these cases, then j which is not equal to 1 now by using Newton's second law. So what is the Newton's second law? That should be a force, that should be a change in momentum, by time. About then force F is equal to then dpi vector divided by dt, which can be written as pi vector. From equation 1, how to write? Then we have to see that then F is equal to then pi vector. So then F force can be written as then pi vector, which is equal to then remaining term, then Fi, E is the external force, then plus we have to write everything. That should be a j is equal to 1 if j which is not equal to I, then n, here I, then Fij vector we have to put, this is the equation number 2. So I hope you have to understand, this is the center of the mass with respect to vector, then r can be write like this. Then similar equation we have to follow. The next, by using the Newton third law. So what is the Newton third law? You know very well about that. So by using Newton third law, so from third law, then Fij vector is equal to then minus Fji vector. This is equation number 3. So ith particle interact with j, then j particle interact with ith particle. Okay. So next, from equation 2, so from equation 2 we have to apply that. What is the equation number 2? Then summation I, then pi vector, which is equal to then summation I, then Fi, then external force, plus, that is the important, what is the equation number 2? Then we have to take summation I, then summation j, then Fij. So in the equation number 1, we have to take the summation on both sides. Okay, then after that, then pi can be written as then from the Newton's second law, then pi vector divided by then dt is equal to then summation I then Fy external force vector plus then summation I then summation j then Fy j vector. This is equation number 4. Okay, next we have to solve this term. About summation I then dou pi vector by dou t which is equal to then summation I then d by dt மட்டும் நம்ம எடுத்துக்கிட்டு then p can be write it as then mass into velocity then mi then vi vector. Okay, next it can be write it as then summation I is equal to in the equation என்ன பண்றோம் just we have to mi வெளிய எடுத்துட்டு then dou by dou t then vi vector. So vi vector எப்படி எழுதலாம் then vi vector can be write it as then dou ri by then dou t. From that equation then summation mi then d by dt vi can be write it as then dou r by dou t. Okay, so then summation we have to put I. Okay, mi is equal to we have to then dou square ri vector by then dou t square. Okay, final we have to get summation. So then summation I then dou square dt square is equal to then mi ri. Okay, so இதோட வேல்யூ தான் என்னது இது summation I then dpi vector is equal to then dt. This is equation number 5. Okay, I hope you have to understand. So from this equation put in equation the above equation put in equation 4 இந்த equation எங்க substitute பண்ண போறோம் இந்த equationல substitute பண்ணி போறோம். So இந்த equationல then summation I dpi is equal to இது we have to substitute பண்ணா we get then d square that should be a you see that equation 4 this one d square by dt square then summation I then mi then ri vector which is equal to then we have to write similar in equation 4 summation I is equal to then Fy external force vector plus summation I j then I which is not equal to j then summation j is equal to then Fy j. Okay, this is equation number 6. Okay, the next again we have to simplify this one then summation ij then Fij vector which is equal to then summation j I that should be Fji vector. So the ith particle interact with j then similarly then j particle interact with ith particle. Okay, we can write it as this one then summation ij then Fij vector can be write it as then of that should be then summation I j then Fij vector plus summation j I Fji vector. Okay, I hope you have to understand. Okay, then next by using Newton's third law from third law then Fij vector which is equal to minus Fji vector. From equation 7 becomes so from the last equation that is the 7 from equation 7 becomes that should be a summation I j then I which is not equal to j then I j vector plus summation j I, then j which is not equal to I, which is equal to 0. That should be f j I vector which is equal to 0. This is equation number 8. So using equation 8 from equation 6 we get from equation 6 level we have to substitute this one, then d square by dt square, then m r vector which is equal to then summation I, then fi, then external vector we have to get this one, then m, then d square r by then d square which is equal to then total force summation I is equal to then fi external force, so which is equal to then total external force acting on the system of particle. So after we have to find out the total linear momentum. So the total linear momentum of the system is expressed as, that should be then P is equal to summation mi into ri dot. So it can be write it as then dy by dt, then summation mi into ri, then P is equal to, from previous equation we have to solve, we have to get then m is equal to r dot. This is equation number 9. So from equation 9 the rate of change of total linear momentum is, that should be then we have to differentiate, then p dot is equal to then m r double dot which is equal to then fi is the total external force. This is strain. So from this equation we have to conclude the center of the mass of the total external force acting on the entire mass of the system. That is the first point. Then second one, the total external force vanishes and the total angular momentum will be conserved. Okay. So thank you for watching. So if you have any doubts or queries, please give your question in the comment section. மீண்டும் ஒரு வீடியோவில் சந்திப்போம். நன்றி, வணக்கம்.